Hi folks, Dr. Pingle here. I'm going to present how to take thermal data and add it to an RGB point cloud in CloudCompare. So to start with, we've got some thermal data from a Pix40 reconstruction here. So the spatial quality of this data is a little on the low side. You can see that we've got sort of a general pattern of the environment here, but not as tight as I would like. And this is not particularly unusual for thermal data. The resolution of this camera was only 300 some by 200 pixels. This was a FLIR Pro R. And so the quality is just a little on the low side. And so what we want to do is attach this data to RGB data where the structural data is actually quite good. So we'll start by visualizing this, and you can see that the output of Pix40, as is quite common, has encoded all of this as an RGB field. And what we want to do is sort of convert that to a scalar field. So there's a nice button under Tools and Color, and we can just calculate a composite this way. And when we do that, we've got a scalar field that then we can apply sort of a pseudo color. And we could, for instance, use like a blue, white, red, and we can start to see some of these buildings and a track showing up as red, and then some cooler areas. There's some trees over in this area that shades this out a little bit and keeps the area a little bit cool, and sort of mixed values in the center. And we could tidy that up, sort of figure out what the mean is, and we'd get a little bit of a clearer picture there. The RGB data is in a separate project. So we will jump in there and bring this cloud in. And when we do that, we are going to be able to interpolate the one to the other. And the only thing that we're going to need to do is get things lined up a little tighter. You can see that we've got, in this case, this is just a shift in CloudCompare, and so we can move that without a problem here. But these 2-point clouds are not nicely aligned. They're aligned a little bit better than this. This is just a CloudCompare. I'm going to hit F3 and get some perspective mode so they both look a little bit normal. But what we want to do is move our thermal data over to the RGB data. So we're going to grab this tool. Actually, make sure we've got our thermal selected. We're going to grab our translation tool and just right-click and kind of move it ballpark close here. I'm going to take a top view and hit F3 and put this back in sort of an orthographic mode to try to get this track lined up with this track. Right mouse button, bringing these into rough alignment. And you can hit the pause button here. You don't have to exit out of it. You can hit the pause button and zoom in and sort of see we've still got a vertical separation here, so we'll bring that down. I tend to like to do the X and the Y and the Z in separate ones, and I tend to be very careful about the rotation here, which you'd activate with a left mouse button, so you want to avoid that. But we're going to unpause, and then we can move our cloud down to align it. And I want it to just sort of pop just a little bit above the surface. You can see that we've got sort of a mild rotational error here, and the reason for that is we have ground control points on the whole project, but even though we were using ice packs for thermal ground control points, some of those were not resolvable because the resolution of the thermal camera is just not quite what we had hoped for. And so getting a full alignment was not easy to do. We could sort of back calculate some from the RGB point cloud, and that would be a perfectly reasonable solution. But there's a lot of this that you can actually do in CloudCompare, which is what I wanted to demonstrate here. So we'll hit the check mark here and take a look at our cloud. And one of the things that you'll notice is that we're still a little bit off. So we're going to use these features to sort of get a nice alignment. So this building goes here. This building is here. So we can continue to edit these a little bit. Here we'll use a X and Y shift to kind of bring these into alignment. And that is pretty close. So we've got a mild misalignment right here. This building is not quite aligned. We might want to bring the track up just a hair as well. Here you can really see that this building is not quite where we want it to be. So we can move that over. There's actually an interesting issue with this point cloud, which is that the scale parameter is not quite right. You can see that once we align this building pops out. So what we can do, in effect, the thermal is a little bit too large, and so what we're going to do is we're going to fix that by applying a scale. So we're going to multiply these out by what I think a good number here is about 0.975. It's going to be the same in all dimensions, and we'll hit OK here. We're going to need to do just one more round of realignment. So I'm going to grab the thermal and move it back up where it needs to be. And then move it over to where it needs to be. Let's move it up just a little bit more. Okay, so now we can do one more little kind of recentering. Trying to use our buildings to help us get this in the right spot. So that looks pretty close, and you can kind of make an effort to really get this perfect. I think for my purposes, this is probably fine. I want to check the Z just one more time here. Whoops, that is a rotation. That is not what I want. Let's try that again. You do have to be careful with the rotation. I often will explicitly set that to none for that reason, because if I accidentally left mouse click, then it starts to shift the cloud in a way that I do not want. So we'll try to get this back where it belongs here. And then I want to look at the vertical here just one more time. So right mouse button, and I'm just sort of visually comparing that things like the track look correctly located here, and that the two clouds are about as well aligned as we can make them. So that looks pretty close to me. So the final step here is to do the actual interpolation, and I'll just mention one more time. We've clearly got a little bit of a tilt right here, which we could manually check out as well. And of course, again, if we had really good tie points between the two projects, that would work as well. And ordinarily, we might do this kind of work in Pix4D. We would just merge the two projects together. But in this case, we're just sort of exploring this as a different option. All right, so let's do our interpolation. So we're going to interpolate from another entity. I'm just going to use, in this case, I think I'll use the 6 nearest neighbors, which will help kind of smooth things out a little bit. You can experiment with these options to try to find something that works well for your particular project, and otherwise we'll just let this go. So it's going to have to build an octree. This will take a little bit of time. I'll pause the video so that we can see it happen very quickly. Okay, that interpolation is complete. Now we can take a look at the results. So we can turn off our RGB. I'm sorry, we can turn off our thermal because that information has now been transferred. And we can pick maybe a slightly more appropriate color scheme here. So we'll do blue, bright red. And we'll turn on some iDome lighting to kind of dress this up a little bit. Oh, it was already on. Great. So there we've now colored our point cloud. We can adjust our values here. You can see that there's kind of a nice high point here in the histogram. So we might set that sort of as a hot and cold. You can sort of pick that for whatever makes sense for your application. But here you can start to really see how some of these buildings are much warmer than their surroundings. So these dugout buildings by the baseball diamond, the trees providing a lot of really nice shade over here, all very visible in the data. The camera itself, again, relatively low resolution on the 300 by 200 or so pixel range, 320 by 240 or something in that ballpark. And so some calibration and some tuning would probably even out some of these spots. You could use a larger neighborhood to try to smooth that out a little bit as well. But hopefully this gets you started on a way to apply a scalar field of any kind back to your RGB data and working with thermal data in particular. Thanks.